So good morning all. We are starting your second day. I hope everyone is quite awake and to follow the day of lectures and discussions. So it's with a great pleasure that we have Erno Langenberg with us, which we met a few years ago in Porto, and I'm really happy that you are here. It's been nice to be with you all during these days. Erno is the founder from L Studio. I think he's where he's developing his practice mainly, and also some of his research. He's a lecturer of the Amsterdam University of Applied Science, where he's also does research on digital production research group and robot studio group. So he's going to present his work and here on the named lines of code and code of clay. Thank you.
Okay, let's start. Good morning, everybody. It's very early, well, for some. And well, I would first like to thank everybody for being here, and especially the organization for organizing this amazing event. It's been a while for me. I was in 3D printing and clay. So it's very nice to be here, and also that it's live. I think it's an amazing experience. So I'm going to tell you a little bit about the work I did, which is done in the period of 2014-2019. And I start with a disclaimer that it was all done in an artist environment. So that's why I never wrote a paper or keep my data. So I now realize that it's important to do so. So you never know, I might still do that. So I did it in several places. Some of them are in Holland, and one of them was in Scotland. And after that period, I will tell you a little bit about what I'm doing now, because it's also quite related. This is the lab I work in Amsterdam, and I worked on it for 5 years now, and we started from scratch. We didn't have any robots then, and now we have around 4 more to come, and we're going to move soon. We have quite a big team, and we work mainly on wood and indeed 3D printing with these nice robots. And for example, one of the projects, I will not get to show a lot, but this one is done with upcycling wood. So the idea is that there was a factory which had a lot of offcuts, and we were trying to make a desk for the Amsterdam, for Ajax, the stadium, where it is placed. And the idea is to use the robots in a kind of smart way to make this desk possible and optimize the use of the elements which were existing. So we try to write an algorithm that we use the planks in a smart way so we don't have to cut too much. And ultimately, the goal of the research department is to have a kind of factory all mechanized and in a smart way to start using waste wood, because there's a lot of it in the building industry, and it could be, now it's burned most of the time because it's quite complicated not to get the nails out and to use all the materials. And we also do 3D printing, but that research is still in the starting phase because we spent most of the time still on making the machines, because we're a technical school. The students mainly work on the tools themselves and making it work. Yeah, let's see, because I added some slides after seeing the exhibition, which I thought was quite interesting 2 days ago, where it says that a lot of different disciplines work with the same question. And I'll just go back to this one, because what I realized is that in 3D printing and all these different tasks the robots do, it's all about lines and curves. It's just a continuous movement of the machine. It goes around somehow. And that reminded me of another project I did before, which was a coin I designed. It's a legal pay means. You can go to the bakery with it if you want. And the idea was that it would represent the signing of the Treaty of Utrecht. And it's just built up by a script which makes lines. And in other ways, you could also think about it like the robot movement could be a dance or an informed drawing, like, and if you would put it simple, it's just a matter of connecting the dots. And then, of course, you could make it as complex as you want, because to do it by hand is one thing, but of course, the robot can, or the computational power you can use to make a very complicated drawing, connecting all these dots. So that said, I will go a little bit to the beginning. I will go in time, so I switch up and down. But this was the start of my research, trying to combine the computational drawings I was making with making and projects in Africa I was doing, thinking that it would be better to make a different way of architecture, that it would be possible to use local materials with a 3D printing or other digital means of factory to go back to a more local way of producing instead of carrying these materials all over the globe and making it a polluting industry. We talked about this guy before. So that brought me to 3D printing with clay, which is in a sense a very old technique. It's like coiling clay, which is one of the first techniques they used to make pottery. So these are very old. And what they do in ceramic normally is they kind of squeeze the layers together with the hand to make them adhere much better, which is of course different if you 3D print, then the layer adhesion is a bit less. And it is quite interesting if you think about this coiling, then there's a lot of artists also work with these, and they have a completely different approach. Of course, they just use the coiling for aesthetic reasons, but you can see there's really different ways of going about it. These are all done by hand. There's no robot involved. It's quite elaborate. But one thing I thought was to use this coiling to make a vase, of course, a very perfect way. But in architecture, you would like to have openings in this kind of structures eventually. So I came up with two basic principles, like either you rotate the vase, it's the simplest way, or you try to make holes in it for some reason, in some way. So that's where I started to think like, I'm going to explore these two ways of looking at it. And as most of you already realize, there's a lot of different knowledge comes together when you have to make a machine, you have to think about the clay and the materials and the computational design. And some of them, they all have to work in the same way. And one of the most important key elements to bind it all together, I realized, was the slicing. And most interesting is not to use the standard way of slicing. It's what you use for your home plastic printers. You just throw your 3D model into a black box and something comes out and you're not interested in whatever happens in the middle. But that's, I think, is where you could make the difference. And in the beginning, it was necessary for clay because there was no other way. And now there's different ways of doing it. So that led to the first elements I 3D printed, which were basically the rotation of the vessel, like, yeah. And that, I really, yeah, I thought it was quite interesting that you could just use this script to make differentiations between the different elements. And that's where I also met Ulrich. I came to him with these little models. And yeah, what's there to say? I think it's quite interesting that you can learn from making these elements and that it informs also the 3D printing process back. Oh, this is a dark one. This is a later version, but with the same idea. I saw that yesterday in the lab, there was also somebody who put a glass in it. And this is a glass I found on the beach. So you could just add it because it melts roughly at the same temperature. You have to be careful indeed, but there's ways of putting it on the plate so that it doesn't crack when you take it out, if you use sand or other means. But most intriguing I found was to put a hole in the other direction, which is of course very difficult because the material will collapse. It's very difficult to use clay for bridging. And well, there's tons of different ways to go about this problem. Of course, you could use the geometry. You could say, well, I'm not going to make a round hole. I'm going to make it a kind of like an archway. Or you could invest time in making the material more stiff by putting fibers or an array. But I thought, like, let's have a look at using a secondary material. Yesterday, there was already, we were talking about it in another presentation. And I thought, like, everything burns away in the oven at 1200 degrees. So it would be perfect to put some other material as a support. And then you could make any shape possible if you would like. You could even go really with intricate shapes. That was the start of the process. And then the practicalities is that at that time there was not really a decent printer, so we started building ourselves. Or mainly I started building myself a printer using materials available, which worked, and then also developed a dual extrusion, which is kind of interesting, but also time-consuming and a complicated thing. And we tested a lot of materials, and oh no, this is the next slide. So we tried a lot of organic materials, materials which were around in the kitchen, like the polenta and what else was there? Potato starch and in different mixtures, but also sawdust, mixed with benton. Benton is a kind of clay mixture in different means. And initially, I just started to look at what does it do in the kiln, because that's the most important. Because most of them don't disappear. You think it disappears, but there's something in it. Like polenta, for example, became a glaze because there's some salt in it. So it's not. There's a lot of practical problems which will appear when you start doing it. Also, the shrinkage is really complicated because it has to shrink at the same time as the clay will shrink. Otherwise, you don't have any benefit. And eventually, the one that works the best is the one on the left, which is the kind of benton mixture, which didn't disappear, but powderized. So it became very easy to get your little clay model out of it. And it didn't leave any, well, almost no markings on the object. I was checking the time where we are. And of course, you get a lot of failures when you start making printers yourself. But also good accidents, because I thought like this way of always having this aesthetic of the coiling, the horizontal, couldn't we do this any different? And I used the secondary material to print on the first one. So you would get a different expression. And you could see here some of the results. So that led to a whole different way of the prints. They look very different. And you could eventually also think of maybe a kind of functionality to this, or a kind of structural way of enforcing the first print in the places where it should be enforced. But for now, it was just an aesthetic approach. And then another way I was looking at opening up the vessel was just by using different layer strategies. This looks like the lamp from yesterday, but it's slightly different because they use the same layer, but it moves out of the, let's say, out of the circle. But these are alternating layers. So one layer is circular and the other one is radial. And that makes for the openings and also the sagging of the clay, which you can control, and it becomes a kind of aesthetic element and also an opening. And then I started making a lot of them. They're basically all the same script with different sliders, which you can use, and more. And then if you add them all together, you could have a kind of ornamental column in this way. unfortunately, this is not a structural element. But I thought it was quite interesting to showcase the difference between the element while they're all secretly the same. And nice feeling. And one of the last tests I did was printing within a mold. Yesterday, there was also a project where they printed flat and then on the mold. But with the Lutum, you could, it's not that easy, but you can also print in a mold. You have to be careful because automatically it homes. So imagine if you're in the mold and then the print is finished, it wants to go out. So you have to change a little bit the code. But it is possible. And yeah, of course, you can imagine it's not ideal. The robot will be much better at it because you can imagine if you have a wall like this, if you print here, it will be very difficult because of the steepness of the. But you have other freedoms because you can then make these more intricate objects and real 3D shapes. Let me see. So you can also change layers. Like for example, this one is a little more complicated. It seems to appear that much more layers than here. To compensate for the, I said it, the weight at the end is less heavy. So, and there's other ways of going about it. You can just coil around, and then if you coil enough on the same place, you could make. I said it. Whatever you want. The last project I want to see is the most recent. This is all old 3D printing work, and this is a project I'm still working on. It's for a city in Nijmegen. They work with local clay and artists who use the local clay to produce objects. So they have, for example, throwaway cups for coffee, which you can drink from, and then you can throw them in the river because they're not baked. Stuff like that. And they have a little place, a little laboratory, and I was supposed to make a facade for the entrance of the building. And it were aesthetic tiles because of the building is already there. But normally this is the building, and if you would put a projected grid on it, you would have a lot of exceptions at the edges, which you could think of printing only the edges. But I thought, like, well, if we start printing anyway, we might as well print them all in a different way. So I did a small study of how could we divide this wall into something aesthetically pleasing, I would say, but still tiles which you could print with the printer I had at the time. And then we started to make a plan for how to make this. And these were the steps which were involved, because you have to take the digging was already done, but you have to prepare the clay, 3D printing, and we were only using the local available kiln, which was rather small. So that's why also the tiles were rather small. You have to glaze and fire again, but it would require a lot of time, and we didn't have that time for the project. So we were looking for solutions. It's not here. But one of the solutions was to make a little print farm. So the 35 days, you can imagine, if you have 35 printers, you can slash the time a lot, but the kiln time would stay. So in the end, it was still kind of a long project. And we were about to start, and then the project developer decided to destroy the building. But it was very unfortunate. However, we still are in the project, and now we think of, which is a kind of nice chance, because we can start again, and we think of taking the kiln out of the process. So we're looking now into ways of using the local clay with some kind of organic binder, or I don't know, we're still looking at it, that we can skip these 2 steps to speed up a bit, and maybe eventually also scale up, because then the kiln is not the limit anymore. So I don't know where we're going, but I go there next week with the printer, so we'll see. But this led me also to think that what I another presentation, I thought like, yeah, this process of locally making something with materials it's very nice if the scale is also a friendly scale of a facade. But if you would print the whole building, you would need a crazy amount of bricks. And how would you go about this then? If you would still use it in a small facility or not? Or would it look more like something like this, like a big factory? And where would the print be in this process? And I find that a very interesting question. Like, how would you go from a very small scale, local, more art-like project to a more industrial way? Where can you place the printer in such a process that it would make sense? And maybe even, I thought with a robotic pick and place, you could imagine a kind of a print factory way of going about making a facade. This I will skip. So that this is the last slide, which I think I was also reading a lot about ceramics, and I thought this was a very interesting project of a Dutch artist, designer. And she used failures in the industrial process to give character. These are porcelain plates, and on purpose she put the temperature a bit too high in the oven. So all the plates are deformed, but all in a different way. So it was her way of giving a personalized, authentic way of using the industrial process. They're a pain to stack. I have a few at home, but it's not easy. But it's I think it's an interesting thought, and also like it's very difficult to make ceramic objects printed identical. Because, well, you know, if you put them in the kiln, some of them twist and others don't. And so I thought, like, maybe we should go about building in a different way. Like, this is a typical Portuguese house. So I thought, like, those stones are also not identical, and still you can make a kind of rectangular shaped house. So maybe we should not aim for perfection, but somehow in a different way, try to go about the 3D printing process. That's it.
So regarding questions, if there's someone that wants to any question here, or Philippe or Bene, you could please write, or questions here from the audience. Philippe.
You show a lot of different materials that you export steel materials, or like raw material print as a export material.
Mm-hmm.
You like give your takeaway from this study of which classes of materials would you do out of different useless materials, and which materials you as candidates that might be worth another shot.
Yeah.
You just tell them the question.
Oh, yeah. The short is the question about what kind of support materials I tested make good candidates for further research. I go back to the slide. Well, I forgot to mention, because first of all, you also need to be able to print it. That's the first, because yesterday you saw also that a lot of these tests are either too thick or too thin, or it's not that easy to make something printable at all. And also in the oven to turn away. But I thought for me, this works the best, the not organic ones. So like the mixtures which would pulverize in the kiln, because the organic ones are all difficult to control. And there's also always something in it which might be dangerous. Like imagine if there's salt in it, it's very dangerous for the oven. Normally the owners of the oven are not happy if you put salt in it. Because it destroys it will stick all to the side of the oven. So you have to be very careful what is in there. So I think the best way would be to go with something which would be powder. And then it's also easy to clean. You know, you take it out and you can spray air or shake it. You have less chance of having a glaze because some of them look quite promising and yeah, it's a bit difficult to see. But then they just turn into a little pool of glass. Actually. So I think that's the takeaway.
Thank you.
Any other question?
Doing many with two different materials. So the natural materials so have unclaimed air is red and one's yellow or something, but they should have different properties. If you burn it both at once, is there any significant difference in the actual formation or drying process so that you know, okay, this clay expands by 30%, while this is shrinking 10%? Do you have to watch for that, or is can you see with a sign saying that nothing is 2%?
So if I understand correctly, the question is if you use two clays, which are different, if it makes problems in the process. Yes, it's short. If you would use a different clay, it shrinks differently, unless that's what you want. But I guess you don't want them to shrink differently, and all of them are different. Stoneware clay or porcelain clay porcelain shrinks much more than stoneware, for example. And I don't know if between batches, I think it's not too much of a difference.
As long as we're on the same dish.
Yeah.
Usually they put it in the big pan and mix it evenly from seconds. So they stay in quality for a long time. So
Yeah, exactly. And they mix a lot of material just in order to get the same quality. So well, in this case, it's they're not different clays. There's iron added. So iron oxide makes for the color. It's like a pigment. Yeah. So it didn't change too much because you only need a little bit of iron oxide to have a color, and it doesn't change too much the properties of the shrinking. So in essence, it's to the same place. Yes.
With a question regarding
Yeah.
So you can just tell a bit more about the first step. We are basically how do you sort them and how do you what that to put it to the gateways? How do you need this gateway? I support you don't it by mailing and
Yeah. Well, there's two things. Of course, one is how it's done now, and one is how it's supposed to be done. Because ideally, let's see, this one is the scanner. So ideally, the wood would come in on a conveyor belt or some kind of, and then you would scan it, make a database, and then you would go from there. But in this case, where we had the scanner already, but it was, it's quite something to go from the scanning to a database to read out the point clouds in a proper way. So in this case, we just measure it by hand, but that's not ideal, of course. And the wood was from, I say that? A wood factory, it's maybe not the right word, but a small wood facility. So it was not old construction wood. So this didn't have nails and difficulties. But we realized when we started building that even sometimes the planks look straight, they are not. So yeah, it's a thing you think of making. The robot is capable of making it very precise. So the first cuts we did with almost no tolerance at all, which would work, but in the end, accumulated curvatures of all the wood, it didn't fit. So the next slots we had to make a little bit of bigger, because otherwise, yeah, you would get a problem at the end, which is a pity, but it's also something you have to work with if you want to start using this material. I think it's quite interesting that the material is not straight. And I think none of the material is. So you have to deal with it in some way. Hmm?
I was listening to your presentation. There's a lot of interesting aesthetic quality, and also mentioned you build your own tool.
Mm-hmm.
So I was wondering, after we did this plan called lines of code, a line is very easy to construct if you experiment with funny-shaped extruders. You can have either like a star-shaped extruder, and that would be a line anymore. So if you follow patterns, that's what I was wondering if you did any experiments with that.
No, I didn't, but I thought about it because I know there's people who I'm going, why is this not working? I just click. Hmm?
You managed?
Yeah. Somehow it was strangely scrolling. Well, I don't know actually what picture I'm looking for, but it's a quite common process in ceramics that you extrude certain shapes. And there's this big extruders, and that's also how they make bricks, you know, like the porous bricks. It's basically also an extruder. So it works exactly the same. So you could use it, and I know but it's more in an art context that they use stars to make like, or it's like also that you use the chantilly, what's the whipped cream. It's also you could do the same. So I think it's a quite interesting way of going about it. And there's also, I know there's something which I think for technicians would be some interesting to explore. Now everybody uses a small auger, a screw, and the clay, if it comes out, naturally it turns again. That's that's quite a problem in a way. Yeah, the tool on the left is done. If you let the clay come out, it keeps the turning of the screw. And yeah, if you don't do anything, it starts turning around by itself. And I use that in that example, but in general, you don't want to use that, no, of course. But I was talking once with an engineer that it would help if the extruder would not be that thin, but with a ball. So the clay would have place to go and extend, and then would go back into it. So, but it's a very technical, you could do a PhD on that, I think. Just the extruder.
Thank you.
But let's see, say, sorry, just before you to first, it was an experiment, and you the statics of it, and usually it's the that's really grabbing to and work with these I have to say, analysts some people want to issue goals to so you put so these solutions.
Okay.
Thank you.